So to evaluate this definite integral, first we need to be able to find out what the antiderivative of this is, and that can be challenging because we need to find something so that its derivative would turn back into this pretty complicated looking fraction. So this is a good chance for us to apply u substitution. We want to make this, we want to make the expression that we're integrating, we want to write that into something that's much simpler so that we can find out what the antiderivative is. So it's kind of a guess and check process here, which is something we try to avoid in mathematics because we like to have just like concrete ways of doing things. But since I know when I differentiate cosine, I'm going to get negative sign, my guess is that we're going to want to let u be sine of x plus cosine of x. That lets me rewrite this entire denominator as just u, so it's much simpler. And I'm also hoping that I'll get this expression up top, but I think I might have looked at the signs wrong. Let's see what happens. If you differentiate this with respect to x, then you get cosine x minus sine of x. So I think I have it backwards because the signs are different, right? Actually, it doesn't matter because you could just factor out. Look, this is the same thing, right? If you factor out a -1, then it's sine of x minus cosine of x. And I think we actually have to let u, because the signs have to be opposite of one another for this to work. So I think that's the only way we can do it. If you let u be the denominator, then the derivative of u can be rewritten so that we can make a substitution up here, okay? Before we make any u substitutions, though, I'm going to factor out a negative sign. That way I can rearrange the top so I can change the signs. And actually, yeah, that's what I need. I need a -1 up top. Right, this is the same thing as what we started with, because a -1 times a -1 is a +1. So I haven't implemented u substitution just yet. I've rewritten it a little bit so that I can see I have a du and I have a u, and all my x's have been substituted. So now let's put things in terms of u and du. So this is -1 du in the numerator over u, or you could just move this du off to the side. It doesn't have to stay in the numerator. Same thing. Okay, now everything's in terms of u. Oh, sorry, you actually want to erase these limits of integration. You'd have to rethink them because now you're not in terms of x, now you're in terms of u. So what's easiest is just to drop the limits of integration until you have your antiderivative, and then plug them back in once you plug in what your u is supposed to be. So I'll show you what to do there. First, oops, sorry, this is not... Here, I've got to go back because I've made two mistakes here. First, when we make the u substitution, let's drop the limits of integration because those were in terms of x before. And second, there's no -1 at the top because this is our du. So I should have written this. Okay, and now we can find this antiderivative. We know the indefinite integral of 1 over x with respect to x is natural log x, right? Same thing here. This is going to be natural log u evaluated between our endpoints, and then there's no constant c because this is a definite integral. Before we evaluate this integral, though, before we finish out by evaluating the limits of the integration, now we have to put it back in terms of x. So we're going to plug in sine x plus cosine of x. So this is natural log sine x plus cosine of x back in for natural log, and then the limits of integration go between 0 and pi over 6. And so evaluating for pi over 6, if we plug that in, pi over 6 in for sine, let's see, pi over 6, that's a 30-degree angle, so the opposite is 1/2, so this is natural log 1/2 plus square root of 3 over 2. Just double checking my work there. Yeah. And then we need to subtract the natural log of sine of 0. Oops, so let's just evaluate that. Sine of 0 is 0. Cosine of 0 is 1. then simplifying a little bit more, this is negative 1 times the natural log of 1/2 plus x. So we can just combine because those have common denominators. This is 1 plus the square root of 3 over 2. And then natural log of 1 is just going to be 0, right? What power do you raise e to make it equal 1? That's just 0, so that simplifies a bit. And then you can distribute the negative sign, so this is negative natural log 1 plus square root of 3 over 2. Now there's other ways you can write this using the properties of logarithms. I'm just going to pause the video real quick to see what WebAssign's looking for. I just typed this into WebAssign and it's fine with this format. So if you get to this point, that's good. You can plug that in. That's the correct answer.